Let's start with the last part. Now we will run a simulation to access the results and save nice images from a macro. A simulation would be the next step after generating structures. So we choose a flow simulation. Therefore, select Predict, GeoDict. Here, from the pull-down menu, choose the first one, the Stokes-Brinkman equation, and then click Edit. Again, to make sure that we will start the simulation with the same settings. Load the build and default settings with the third icon here on the bottom left. Then we are asked if we also want to use the build and default materials, which in this case makes no difference as our structure comes to have the build and default materials. I will just click No. As for most structures, this would be correct. So then we close the dialog again and click Run. The results are shown in the result viewer, and we later will be interested in the permeability value here, but for the moment we just close this result viewer. Now open the session macro dialog again, and here we can also see that the macro execution and vary Python macro are GeoDict commands that can be recorded, so that you can also run a macro from another macro. But we only want to get the GeoDict solve Stokes command. However, we will not save it in a new macro with this command, but instead we will attach this command to our already existing workshop macro. Because analyses like the flow simulation always happen on the currently loaded structure, and we want to run it on the different fiber structures. Therefore, just select it and click Copy to Clipboard. This will only copy the selected commands with the parameters, so we can just take this command and append it to our existing structure generation macro. After clicking Copy to Clipboard, we then move to the editor again, to our Workshop 3 macro. First we save it under a new name with File, Save As. Then we change the 3 to a 4 for Workshop 4Pi and click Save. Then here in the macro, scroll right at the end of the macro, and by right-click and clicking Paste, paste the GeoDict command. Then we see here the GeoDict command, and above the GeoDict parameters dictionary. The first line of this dictionary is the result file name. And of course we want to edit this name again, so that the variable values are part of it. Write an F in front of the string, and here append underscore GDSVP in curly brackets and underscore GDFD in curly brackets. And now we can also change the description again. Scroll up to the beginning of the macro, and in the first line of the description add and runs a flow simulation. Click Save and go back to the macro execution control. Click Refresh, highlight Workshop 4, and now we can see that the preview changed to also containing the GeoDict command. And in the description panel we find our new description text. Click on Parameters, and for the solid volume percentage, again enter 10, 40, 70. And for the fiber diameter, enter 10, 20, 30, as we did before. Couple the variables by selecting solid volume percentage for fiber diameter, and click OK, and run. Now 3 fiber structures are generated, and the permeability is computed for each of them. Of course, we already generated these 3 fiber structures, so we simply click Override for all of them. So then override the second one, and permeability is solved. Override the third one, and also permeability is solved. For the third one with the 70% solid volume percentage. If we now look again in our project folder, we can see, additionally to the fiber structure results, the 3 Stokes result files and result folders. Now we want to access the simulation results. As each structure generation or simulation produces a single GDR file containing all result values. Therefore, we move back to the main GeoDict user interface, close the session macro dialog, and open one of the GeoDict result files. Either here by clicking on File, Open Results, and then browsing for the result file. Or you can also open result files and also structures and volume fields by drag and drop. So here, if I take my file explorer and drag the Stokes result 1010 and move it to GeoDict, it is opened in the result viewer. Here all the results from the flow simulation are stored. We can see a nice report of the results, and here, right at the top, we find the permeability tensor. The first 2 columns are empty, as flow was only simulated in Z direction. Of course, we could change that either in the GeoDict user interface or in the parameters dictionary in our macro, if you wanted. For now, we are only interested in the permeability value in the bottom right. So in the 3rd column and the 3rd row, which would be position 3.3, then we move to the map tab here, which is a subtab of the results. And we find a list of key value pairs. These keys we need to access their respective values. We want to have the permeability 3.3 value here. So we have to remember this key and that it is in the results map. With this knowledge, we go back to our workshop for macro and save it in a new name again. File, Save As, and now workshop 5.py. Just click Save. And then we first change the description again. Simply add in the first line and returns permeability. Maybe we could also change the first end to a comma. And then in the first line of our macro, add a new line, import string map. This imports the Python module string map, which will allow us to access string map files. As GeoDict result files basically are string maps, this is exactly what we need to access our flow simulation results. Now scroll to the end of the macro, right below the GeoDict command. And here, while scrolling down, we can see the computation directions we mentioned earlier. Here directly below the result file name. Here, true means flow will be computed in this direction, and false means it is not computed. So if we wanted to, we could also select the other 2 computation directions by changing false to true. But we just continue scrolling down until after the GeoDict command. We will store the GDR file in a variable which we call GDR, and here we right away need the module string map. And there we need the command pass GDR. And in round braces we must enter the result file name as a string. And therefore, to be sure, we use the right result file name. We scroll up again, here to the result file name in the GeoDict parameters dictionary, and just copy it. And then we scroll down again and paste it in the parentheses. We only want to have one value in the result file, and that is the permeability we have seen before. It will be a string. So we call the variable we will use for this value perm string. Accessing the values in the string map works similar to accessing values in a Python dictionary, as we have seen in the gdrun command with square brackets. And inside these brackets we have to enter the right key. In this case we want a value from the result map, so we write result map. then a colon, because we now are in the result map. And there we need the key permeability 33. Here we always first need the right map. First it's the result map and then the right key inside this map that we found in the result map. As we would like to have this value as a floating point number instead of a string, we simply transform it. The new variable we will call perm, and then we will use the Python command float, and in the parentheses we will enter perm string. Then we will use the API function again to the MSG box to see the obtained permeability after each simulation. We will enter a string and start with an F in front to format our result values. And in the quotation marks we enter for SVP equals curly brackets and inside GD SVP, and diameter equals GDFD in curly brackets. Permeability is curly brackets perm colon dot 2e. As the permeability value is very small, we format with the E syntax we saw earlier in the strings example. We will only show 2 decimal places in the message dialog. Finally, save the macro again. Then move to the macro execution control, click refresh, then highlight the workshop5.py, and now we see that the preview is gone. That is because we added Python syntax, which is not part of the GeoDict commands, and thus it is no simple macro anymore. Click parameters and enter again 10, 40, 70 for solid volume percentage, and again for fiber diameter 10, 20, 30, and couple it with the solid volume percentage again. Click OK and run. And now we have to override not only the fiber structures, but also the corresponding FlowDict results. Then our first message dialog appears. For SVP equals 10 and diameter equals 10, permeability is 3.15 E-11. Click OK and override the second fiber structure and the second stocks result. Then we get our result for SVP equals 40 and diameter equals 20. Permeability is 2.65 E-12. Click OK and override the last fiber structure generation and the last flow simulation. And here's the result of our final simulation. For SVP equals 70 and diameter equals 30, permeability is 5.59 E-40. And click OK. In this way, any value from the result file can be accessed. You only need to know the right key and the right map, which you can find in the result file. We can not only access the result map, but also the input map, the log map, and the post map. Now in the last step, we also want to visualize our results and save nice images from them through our workshop macro. Therefore, we load one of the FlowDict results again and move to the Flow Visualization tab. Here click Load, and in the opening dialog click OK. In the GeoDict visualization area, collapse the console again, so we have more space for visualization. We can see now the flow field and the structure. Here I have the structure with the 10% solid volume percentage and 10 micrometer fiber diameter. In this workshop we only want to visualize the streamlines instead of the complete volume field. Therefore, above the visualization area you find the volume field tab, and if you uncheck the small box next volume field, you can only see the structure. Then check the Streamlines tab to visualize nice streamlines. Now we want to have nicer colors for our structure. Therefore select the Color and Visibility tab here on the right. And as we can see in the material legend on the left, our structure uses the material ID 0 for the pore space, 1 for the first fiber type, and 2 for the second, and finally 3 for the overlap in between. And the air with ID 0 is invisible, as the corresponding checkbox here is not checked, so we don't need to change the color here. But for the 2 fiber types and the overlap in between, we need to change the color. Therefore we click here on the color button and select a nice beige. This we also do for the second fiber type and also for the overlap. Now we cannot distinguish the fiber types anymore, but there's more focus on the streamlines. GeoDict is a voxel-based program, so the structure consists of voxels, as we can see here. But the visualization would be even better if we visualize the fibers with a smooth surface. So here go to the Structure tab, and for Structure Renderer, select Smooth. Then you can see here that the surface became smooth. Rotate the structure until you like the camera angle. For example, I think this is now okay for me. And now we want to save the visualization as an image. Therefore select File, Save Image As, and in this dialog select Preset and choose 640 x 480 VGA from the pull-down menu. And you can also see a preview of the preset in the GeoDict visualization area. Then simply click OK. And let's call the image Streamlines. Click Save. And the image is saved to our project folder. To record these steps, now open the Session Macro dialog again. This time we will need 3 commands, because first we need the command to load the volume field to be able to visualize the streamlines. And then we also need the set view status command, because all visualization settings are saved in this command. And finally, the third command we need is of course the Save 3D Image command. Press and hold Ctrl while selecting the needed commands with left mouse click. Here, first the volume field, then set view status and save 3D image. As we want to append these commands to our workshop macro again, as we did with the floating command, we just click Copy to Clipboard. Open Workshop 5Pi again and save it as Workshop 6. File, Save As, and replace the 5 by 6. Click Save. Then append the 3 commands from the clipboard to the end of the macro, right beyond the MSG box command. In the Save 3D Image parameters dictionary, we changed the file name by adding an F in front, and we will add the variable values again. So underscore GDSBP in curly brackets, underscore GDFD in curly brackets. And then we will scroll up to the load volume field parameters dictionary. Here, while scrolling up, you can see that there are lots of parameters for visualization. They can all be saved and changed in the macro. Here we have the load volume field command. The volume field itself has the same name as for all floating simulations, but the folder name corresponds to the result file name. Thus, changing the folder name is enough here. Add an F in front of the string, and here change the first 10 to GDSVP in curly brackets, and replace the fiber diameter by the variable in curly brackets, GDFD. Then finally, scroll up to change the description again. Change the end to a comma and add and saves an image of the structure with streamlines. Save the file again and go back to the macro execution control. Here we click refresh again, highlight workshop 6, and here we see the final description of our macro. Click on parameters and again insert 10, 40, 70 for solid volume percentage and 10, 20, 30 for fiber diameter. Choose solid volume percentage from the pull-down menu for fiber diameter and click OK. Click Run, and now of course the 3 structures are generated again and permeability is solved for each of them. And we have already generated all these structures and simulated flow on them, so we just can click Override for all of them. Here we have our message dialog again, just click OK. And again override the second fiber structure and the second stocks result. Click OK in the message box. And the last fiber structure and the last flow simulation. And the last message box. Now every result was visualized and saved as an image. And in GeoDict we see the visualization here of the last image with the 70% solid volume percentage and 30 micrometer fiber diameter. Now look in the project folder and find the 3 images. Just open them all by double-click. And here we see the first one for the 10% solid volume percentage and 10 micrometer fiber diameter. And then here the second one for the 40% solid volume percentage and 20 micrometer diameter. And the last one we already saw for the 70% solid volume percentage and 30 micrometer fiber diameter. And here on the workshop slide, you can also see all 3 of them next to each other. Observe how the velocity is much slower for higher solid volume percentages. For visualization, it would be even better if the legends would have the same scale for all images. That of course is possible in GeoDict, but how to do this you can learn either in the visualization workshop or in the visualization user guide. Of course you can reproduce every visualization by recalling it to a Python macro. After showing you how to access simulation results and save images from Python macros, in the end, I want to briefly touch some advanced topics, and we will start with a nice filter-dict example. GeoDict comes with a simple application user interface to generate PowerPoint reports. This is very useful, for example, if similar parameter studies are done often. Then a Python macro can generate a unified report of the results to analyze them and show them in a nice way. This slide and the following slide are generated by a Python macro after another macro generated the corresponding parameter study. Fiber structures with varying fiber diameter proportions were generated. And the solid volume percentage stays the same for all structures, but the proportional percentage of the 2 fiber types varies. On the left, we start with the 100% thin fibers with 4 micrometer diameter and 0% of the thick fibers with 40 micrometer diameter. And when we go to the right, we see more and more thick and less thin fibers until we have 100% thick and 0% thin fibers. Then a filter-dict simulation was performed on each of the structures using a standard dust composition. On the images we see that the structures are clipped halfway to see also some particles which are filtered inside the structure. This is only visualization. The structure is of course still there, but invisible. The thicker the fibers, the more particles go through, as we would expect. The first part of the report generation was to save nice images of each structure and 2 plots that we will see on the next slide. And here we see the two plots that were generated with the macro. The first plot displays pressure drop versus the fraction of thick fibers. And we see the higher the percentage of the thick fibers, the lower the pressure drop. The second plot shows the filter efficiency versus the particle diameter. One color for each of the different structures. It starts here on the bottom with 100% thick fibers and 0% thin fibers. And we have a higher efficiency the more thin and the less thick fibers are in the structure, as we have already seen in the visualization on the slide before. How to generate PowerPoint reports you can learn in the GeoPy Advanced workshop or from the Automation by Scripting user guide. Finally, we briefly touch onto some advanced possibilities. First of all, you can also execute macros directly from the command line, including setting variable values, which is a powerful method to integrate GeoDict in your custom simulation and analysis pipelines. Furthermore, we have a set of GeoDict application program interface functions, where we already have seen the GD1 command for the fiber structure generation and the FlowDict simulation, and the GD MSG box. These two could belong to the most important of these, but we also provide functions, for example, to directly access the voxel structure or simulation result fields, and for writing import geo wall filters for micro CT images. We can find an overview of the API functions in the macro execution control. So move to the macro execution control. And here on the bottom right, simply click GeoPy API Help. Here you see a nice overview of all the function names and which arguments are needed and what is the return value and a short description. Additionally, you can find here in the Automation by Scripting user guide, and it will not only explain the macro menu with all options, but also contains many examples on how to record macros, adding variables, how the different variable types work, and even all of the API functions have an example. You can also find a description of our simplified Weber API for the PowerPoint report generation. Then we also ship a set of popular open source Python libraries, which are installed into the Python interpreter within GeoDict. This includes fast MATLAB-style numerics with the module NumPy that could, for example, be applied to volume fields as the flow field we have seen before. And then we have the powerful plotting library matplotlib, which is also introduced in the GeoPy Advanced workshop and allows to plot the results in a user-defined style. Of course, the Excel file generator XLSX to create Excel files from a Python macro. And of course, as already teased, the generation of PowerPoint reports from GeoDict results can be automated. The built-in Python interface GeoPy enables the automation of any kind of workflow. This significantly increases the productivity in the usage of GeoDict. Macros created in GeoDict can be adjusted by using the entire range of Python. Any kind of GeoDict data can be accessed and processed from Python scripts. Finally, your results can be exported directly into PowerPoint presentations. This enables, for example, the execution and individual presentation of parameter studies. I want to conclude the workshop by summarizing what we have shown you. Now, hopefully you can record and playback macros through GeoDict to automate common and repetitive tasks, and also you can add variables to macros and run parameter studies to optimize your materials. We showed you how to access any GeoDict result from a Python macro, to summarize and compare simulation results. I really hope now that this will ultimately help to increase your productivity when working with GeoDict. In the last slide here, the link here on the bottom leads to a great official Python tutorial to learn more about scripting with Python. Thank you for your attention.